All right, so today we get into investigation 4.1 and 4.2, our last section of moving straight ahead. And it says, how is the steepness of a set of stairs related to a straight line graph? So that's what we're going to explore today. So we're going to kind of use 4.1 as kind of like an introduction, and 4.2, a lot of our practical practice and kind of building on it. So it says, climbing stairs is a good exercise. The steepness of stairs determines how difficult they are to climb. So does the steepness of a set of stairs affect the exercise? And the answer there should be sure, right? Because the steeper the stairs, the more of a workout you're going to get. It's going to really work your leg muscles, and obviously if the stairs are less steep, if the stairs are less steep, it's not going to work your legs as much. So yeah, it'll affect your exercise. Do all stairs have the same steepness? Um, no, not all stairs. Some stairs are steeper than others, but usually in the same flight of staircase, they're the same. How can you describe the steepness of steps? Well, remember the stairs, depending on if you're going down or up, right? Um, usually a step comes out and then it goes down, and then comes out and comes down, and comes out and comes down. Or if you're going up, kind of the same thing, right? Goes up and then across. So that's usually describing the steepness, of a step. Okay. And if I go up a staircase, obviously it's a little bit different story where I go up and then across, and I go up and across, and I go up and across, and so on. So is the steepness the same between any two consecutive steps? Usually, I mean, you could probably get out the ruler and go, so exact and crazy, and it might be off by, minute millimeters, but I mean, generally it's the same. I mean, it's very tough to make all things the exact same measurement, but that's kind of a loaded question. So let's see where all this is getting us here. All right, I'm going to scroll this down here. So all that builds up. So carpenters have developed guidelines to ensure stairs are climbable. The ratio of rise to run. So remember, rise goes up, run, okay, side to side. So for each step should be between 0.45 and 0.60. So they got a little bit of ratio to play with. But as long as they hit that ratio, the stairs are climbable. People won't have a hard time going up them. The rise plus the run for each step should be between 17 and 17.5 inches. So when you add them up. So determine the steepness of a set of stairs in your school or home. Well, we're not going to do that. We're going to kind of give what they gave us here. So below are the measurements. So this is kind of pre-done for us. So the ratio of rise to run. Okay, well the rise is 7. Now to use ratio, we use a colon. Okay, and then the run is 11.25. If we add these together, 7 plus 11.25 is 18.25. So the obviously the sum of the rise and run, this number is a little bit bigger than the range of 17 to 17.5, right? Now, if we also try to find the ratio, you can also find the ratio too by taking 7 and dividing it into 11.5. So if you have your calculators out, okay, take 7 and divide it into 11.5 and tell me 11.25 and tell me what you get. You get 0.62 repeating, right? So it's 0.62 repeating. So it's a little bit bigger than that 0.6, but not much. So, if you want to be an Untitled guy, if it's supposed to fall between this, right, and this is still 18.25, right, for step 2. So step 1 and step 2, they have the same ratio, right, 0.62 repeating. So it says, how do the stairs you measure compare to the carpenter's guide above? Well, in terms of the ratio of rise to run, the ratio MSA is slightly bigger. than the max of 0.60, because ours is at 0.62 repeating. So it's 2/100ths of a point bigger than what we're supposed to be. Okay, so yikes. Now, it also says the rise plus the run for each step should be 17.5. So also the rise plus the run is higher than 17.5 inches at 18.25 inches. So would these stairs be climbable? And the answer would be no, because they do not fall within this range here and this range here, according to what those carpenters who build stairs say. All right. So a set of stairs is being built for the front of a new arch middle school. The ratio of rise to run is 3:5. Okay. So remember, we did that work up top, 3:5. So you can take 3 and divide it into 5 to find the ratio of 0.6. Okay. That's the ratio of 0.6. And again, according to the guidelines up above, this is just in the range, right? It's the actual max part of the range, right? Because the range was 0.45 to 0.60 up above. Remember what the carpenter said? So is the ratio just within the carpenter's guidelines? So yeah, we just said that, right? The ratio falls just within the range. So again, 3/5 is 0.6 over, right? So 0.6 is the rise to run ratio, right? So if we made that over 1, this would be 0.6. 0.6, it's actually, it's a decimal written as 6/10, right? 0.6 is written as 6/10. So when we do so, oh, I'm sorry, we're not worried about the rate. We're not worried about the rise plus the run. They just asked us the ratio, and the ratio is it's on the right on the max part. So now it says make a sketch of the set of stairs that meet this ratio. Okay, so 0.6 is the same as saying 6/10. And again, that would mean rise to run or rise over run. Okay. So, with that said, if I were to draw stairs, right? There's our stairs. So if the rise is 6, the run is 10. The rise is 6, the run is 10. The rise is 6, the run is 10, and so on. Okay? So again, we are going up and then across. Up and then across. Up and then across. And obviously that will continue till we get to the top of our staircase. So again, learning a lot about rise over run. All right, let's flip on over to the back. So it says sketch the graph of a line that passes through the origin. Okay, so the origin is this little guy right here. That's where the x-axis and the y-axis meet, right there. Okay, that's the origin. The origin is the actual point that we call 0, 0, and whose y values change by 3 units for each 5-unit change on the x values. Okay, which means we go up 3 units, 1, 2, 3, and then over 5, 1, 2, 3, 4, 5. We would make a point right there. And then we go up 1, 2, 3, and over 1, 2, 3, 4, 5, and make another point right there. So I'm going to erase this because we're going to actually make a line out of this. So let's start doing that. All right, so go up 1, 2, 3, and over 1, 2, 3, 4, 5. There's a point. And up 1, 2, 3, and over 1, 2, 3, 4, 5. Now if I go over 5 now, I go off the board. So I'm just going to keep those points right there. Okay. And I'm going to go ahead and make my line. There we go. And there's my line. All right. So I graph that line. Because again, remember, I'm going, the rise is 3. Right? That's the change in y because we're going up the y-axis. And the run is 5. And notice every time I go to the run, I actually hit that point, right? And I go up 3 over 5, up 3, and continue. Okay? So it says write an equation for the line in part 3. Well, remember, the equation of a line is y equals mx plus b, where m is the slope, which is what rise over run is. Okay, that's why we started to teach you this. So the slope is rise over run. And the b is the y-intercept. Well, the b here, where it hits the y-intercept, is right here at the origin, 0, 0. So there is none. So if I go ahead and write this, the slope of rise over run is 3/5. So we'd have y equals 3/5 x plus 0. Well, I don't need the 0, right? So I could write this as y equals 3/5 x, or I could write it as a decimal, y equals 0.6 x. Both equations mean the same thing. And the coefficient in front of x, the number in front of x is 3/5, or 0.6. That number, that coefficient that's in front of the x, that's the slope. So whenever you see that equation, that number that's in front of the x will always tell you the slope, rise over run. So again, how is the, and I keep answering myself, I'm ahead of myself here. So again, the coefficient, how is the coefficient related to the steepness of the line? The coefficient, big word, but it's a necessary word you need to know because we use a lot in 8th grade as well, tells you how steep the line is. Coefficient tells you how steep the line is. Okay? I'm pretty sure I got a summary in here. Yes, I do. All right. So we'll get to that in a second. All right. So how is the coefficient related to the steepness of a set of stairs? Well, the stairs, obviously, the coefficient or the steepness is the ratio of rise to run. And again, rise over run is 3/5. 3/5, 3 is the rise, run is the 5 is the run, 3 is the rise. All right. So let's talk about the summary here, which is attached to your packet. So slope refers to the steepness of a line. Okay. The line could be going this way, it could be going this way. Okay. So slope is the ratio of rise to run. Rise over run. Okay. So right here is big. Rise is always the, basically think of it as the numerator, run is the denominator. Rise first, run second. Rise is a change in your y values, right? Because the y values go up and down the y-axis, right? And run is a change in your x values, left to right. Okay. So a line could have a positive slope. And a positive slope looks like this because it goes upwards and then across. Upwards and then across. Where a negative slope, okay, you could have a negative slope because the rise could also go downwards, being negative, and then left, right. down, and then right. You could also have no slope where the slope is 0. And that's a horizontal line. That's a line that literally goes left to right. It doesn't change. It does not go up or down. It stays flat the whole time. So those are 3 scenarios you could have. Positive slope, negative slope, or no slope. 3 situations. Okay? So that pretty much takes care of investigation 4.1. And then this is going to lead into what we're going to do a lot now in 4.2 notes. Okay, so go ahead and take out your 4.2 notes as we say this video on 4.1.